So, hi everyone, my name is Tristan Foureur and I've been working for Plivo since a year ago. I work over there as a site reliability engineer. So basically I didn't touch FreeSWITCH until a year ago, and my expertise is more DevOps and infrastructure more than telecoms. So we're gonna talk about DevOps, but for FreeSWITCH. So a bit about us. We're a cloud API platform that allows you to drive calls and SMSs through our API. But we also provide some global carrier services through a new product that we released a little while ago called ZenTrunk, which is a SIP trunking solution. We've had the pleasure of working with a few great brands out there, so a decent amount of volume from them, big ones including WhatsApp, Netflix. So we've had plenty of time to work on this problem. Bare metal servers, we've been using them since the creation of the company, and we've had a few issues, including huge inertia, even with reputable providers. So I'm not going to name the provider here, but it's a big one. It took them around 2 weeks to change VOS on a single server, and it's a provider that everyone knows. It's hard to scale quickly if you need more servers. You know, you're going to need to send a new purchase order. You're going to need to wait for your machines to be provisioned. It's also hard to be elastic. So if you want to save some money and turn off your servers in certain regions because you're going to have less traffic, it's hard to do that with bare metal servers. So what we want, basically you want scalability. You want to be able to scale up and down easily. You want ease of maintenance. Even though you're on the cloud, it should be easy to move quickly. You want reliability. Reliability. You want to avoid downtime. And finally, you want performance. So I know that most people here would worry about running FreeSWITCH on virtual servers. We've had pretty good results with that. We've done some pretty heavy stress testing, and we've had extremely good results with no jitter, no packet loss. That is on AWS. We haven't tried other providers. This talk is going to be focused on AWS. So I want to talk to you about a solution called AWS Opsworks, and it's basically a layer on top of Chef. So for those of you that don't know Chef, it's a configuration management solution similar to Puppet, to Salt, to Ansible. There are many solutions out there. Opsworks comes with many perks. First of all, it has a GUI on AWS. Most open source versions of these solutions don't come with a GUI for free. The enterprise versions often do. Chef and Puppet, they do if you pay some money. But for free, it's hard to get something enterprise grade. It adds the concept of stacks, layers, and apps to Chef. I'll go into the details of that in just a moment, but it's basically a logical way to divide your stacks per logical group to easily maintain them. It still retains all the features of vanilla Chef, so everything that you're used to on Chef, you can use it on OpsWorks. You can manage on-premises servers too, so that means that to use OpsWorks, you don't need your servers to be hosted by AWS. So if you have existing bare metal servers or even virtual servers but are on other providers, you can add them to your OpsWorks stacks. That's what we do. We have some servers all around the world with different providers in some regions that AWS doesn't have, but we still want to have that single layer to provision and to do configuration management. So we just add those to our OpsWorks stacks. It's an agent that runs on the server, and it brings you all the benefits. No additional cost. OpsWorks is free. You only pay for the compute resources that you use. So an EC2 instance, for example, it's going to be the same cost. It's all free, just the agent running on the server. It has built-in basic monitoring, so bear in mind it's basic monitoring, but it gives you an additional layer of monitoring with CPU, memory, disk usage, network. And finally, the core features. So the most basic thing is 24/7 instances. So these are instances that are going to run forever. But you can also have time-based instances. So say in some region, you want to start some FreeSWITCH servers at 8 a.m. and shut them down at 8 p.m. It's easy to do on the interface. You just add the instance, and you're only going to pay for the instance when it's actually up. Otherwise, it's going to be shut down, and it's going to stop running at night. You can have load-based instances. So this is a really cool feature. You can define some rules. For example, you could say, when my servers hit 70% CPU or 70% memory usage, then I want to spin up 1 or 2 or 3 new additional servers. And when they're below 30% CPU or RAM usage, then I want to scale down by 1, wait half an hour, and then do it again. You can define those rules really easily on the interface. And the cool thing is that those are based on the CloudWatch metrics, which is AWS way of doing metrics and monitoring. But you can define your own CloudWatch metrics. So for example, you could define a, I don't know, open channels on my FreeSWITCH metric, so that you could actually do scaling up and down based on the actual number of calls on your servers if you want to target a specific amount of calls and you don't want to do CPU and RAM. So OpsWorks is based on Chef. And for those of you that know Chef, you're familiar with the Cookbooks and Recipes terms. A cookbook is a logical group of recipes. And for example, because everyone uses that example, a WordPress cookbook could have the following recipes: setup MySQL, setup Nginx, etc. And a recipe is a single Ruby file that can basically do anything: install package, deploy file from the cookbooks, create files from templates. So these have dynamic variables so that you can tweak it per instance or for your environment. It can set up users, it can set up cron tabs, whatever you want. Basically, that's where you put all the logic. Now, on OpsWorks, you have the idea of a stack. A stack is a logic group. For example, we could call it voice stack. A stack represents your compute infrastructure and applications that you want to manage together. In OpsWorks, you don't do anything that has to do with networking. I mean, all those features outside of your compute infrastructure. Some of you might know CloudFormation. It's another tool that you would use if you want to take care of that side of it. OpsWorks really only do configuration management and provisioning for your instances. So your stack is on a single region, has multiple layers, and has apps. I'll go into apps and layers just a bit later. Your stack can be configured to pull your cookbooks from GitHub, from Git, from S3, from anywhere, basically. And it will pull the cookbooks, and the instances will get the cookbooks and run them. The layers, they contain all the instances of the same group. For example, it could be FreeSWITCH, Camellio. You can have as many layers as you want in a stack. And all the instances in the same layer, they're provisioned the same way. They run the same recipes. And then you can have apps, which can be your custom apps that you want to pull from your Git repository, or maybe you have a build server that is going to create a Debian package and upload it somewhere. Then your app could be pointing at that. And then the cookbooks in the instances, they can read that from AWS and pull the app and install it on the instance fairly easily. And that gives you a UI as well to manage your apps and to deploy your apps. So let me add also that this is great for people that are not working infrastructure, that are not working DevOps. If you have some guys on your team that are developers but that don't want to care about the infrastructure and DevOps, it's really push of a button deployments. And at the end of this talk, I'll also show a tool that we made, an open source tool, that makes it super easy from your terminal to run deployments across your stacks. So OpsWorks comes with a set of commands. I'll show you the UI a bit later after that. Basically, the commands are how an instance gets provisioned, how you deploy apps, how you deploy and apply new configuration to instances. There are a few commands. Some run automatically. All commands can be run manually. And then you have a really good granularity. You can run these commands on your whole stack, on certain layers, or even on just a single instance if you want to. Now, those commands that you can run on OpsWorks, you have a few. Update cookbooks. It makes your instances pull the latest version of the cookbook. So I've put S3 here, but it's actually S3 or Git or Subversion. You can use whatever you want. And basically, when the instance first starts, it's going to pull the latest cookbooks from the source that you tell it to pull from. But then you need to tell it when to update it. When you do a setup command, it's going to, for example, install the packages needed for a layer or install the dependencies that the app needs. The setup will be run automatically when the instance boots. Deploy should be the recipes that, are, that specify to the instance how to actually get the app and how to install it. And finally, configure is for when the app is already installed and you want to deploy some specific configuration. So for example, for a FreeSWITCH, that would be all your XML settings and the etc FreeSWITCH folder. And then execute recipes is a specific command that you can only run manually for when you want to run a specific recipe. For example, say you have a recipe that sets up your users for your whole team, then if you update that file and you add a new user with his public key and you want to add that user to all of your servers, you'd run execute recipes and specify your setup user's recipe on your whole stacks, and it would add that user, and 1 minute later he'd have access to all your servers. Or if someone leaves, you could also remove him from that file, run the same thing, and his account would disappear from all servers. Now, the life cycle of those commands. So update cookbooks, as I said, you do it manually, but new instances, they start with the latest version of the cookbooks. Setup is triggered automatically when a new instance starts. It's going to provision itself. The deploy as well is going to run automatically. And configure is triggered automatically on all instances of the stack when a new instance comes online. What that means is that if you have, say, Camellio and FreeSWITCH layers on the same stack, if you have a new FreeSWITCH server that comes up, when it's ready, it's going to trigger a configure on all of your other instances, including Camellio. So you could use that so that your Camellio server, for example, or OpenSIPs, is aware of all the running FreeSWITCH servers. So that's an easy way to do service discovery without a hassle. You could have load balancers, whatever you want, and they can be aware in real time of all the running servers. And configure, I didn't mention it there, but also runs when an instance comes offline. So same thing. You have a FreeSWITCH server that goes down, then your Camellio or whatever could be aware of it in real time. Execute recipes, as I said, it's to be run manually. And then shutdown is also a set of recipes that are executed when the instance is scheduled to go down. So for example, for your FreeSWITCH server, you'd probably want to have some logic to make sure that your server doesn't accept new incoming calls, and then give it a fair amount of time, like say 1 hour for current calls to finish, and then go down. So you could do that in your recipes fairly easily. So I'll just give you a quick demo of the OpsWorks UI, if I can get that to the other screen. Let's see, there. Come here. Okay. And okay, let me zoom in a bit. Okay, so here I have a ClueCon US West 1 stack. For example, this is these are my stack settings. It's configured to use a GitHub repository that I'll show the link for at the end of this presentation if you want to dig into it and have a look. It has an SSH key, but it's not really needed because the repository is now public. But basically, you could just put a private key that AWS is going to use to pull that repository, or you could use S3 or something else. And then I have one layer, a FreeSWITCH layer, on which I have 2 instances running. And in this FreeSWITCH layer, you could see that I have my recipes configured here. So this is my FreeSWITCH cookbook. It's telling it during the cookbook to call, during the setup to call the setup FreeSWITCH recipe, and then for configure to call the configure FreeSWITCH recipe. So that's the bare minimum here. My setup FreeSWITCH recipe, what it does is that it just adds the Debian repository for FreeSWITCH, and my configure and installs the package, sorry. And my configure repository, what it does is that it puts the XML files that it needs to run, just a basic configuration. And then here in my instances, I can see my 2 instances running. So these are pretty small servers just for the demo. I'd recommend you get something bigger if you want to go live on production. Just to show you what it looks like, how easy it is to write those recipes. Hold on, let me get a terminal window across. Full screen. There. Okay. Okay, so here I have my recipes, and just to show you how it is. So my setup recipe that I have here is, come on. Okay, so my install recipe, basically it adds just the Debian repository for FreeSWITCH, as mentioned on the documentation, and then it installs the FreeSWITCH meta-all package, and then it tells this snippet of bash here to run, which just copies the vanilla FreeSWITCH configuration. So those 18 lines are pretty much all that is required to have a running FreeSWITCH. What I've commented up there here, I want to quickly mention that Chef has a great ecosystem of cookbooks. So you could actually go to what is called the supermarket. It's a Chef website that has tons of cookbooks for everything you want, crons and all sorts of package managers, and there's even a FreeSWITCH cookbook that you can have a look at. What I've commented here uses the APT community cookbook, which makes it a bit easier and a bit cleaner to add custom APT repositories. But because here I wanted to do something simple, I'm using a bash snippet to add it. But if you wanted to do things a bit cleaner, you'd probably use that over here. Now, this here just notifies the snippet CP vanilla just below to run immediately after the package is installed. It's a neat Chef feature to basically have dependencies between your resources. So just after the FreeSWITCH meta-all package is installed, it will run that snippet of code here. And after it's done all this, FreeSWITCH is installed and ready to go, but we still don't have our own configuration. So that's why we have a configure, recipe, never mind. Configure FreeSWITCH. That's why we have a configure recipe here that basically defines the FreeSWITCH service and tell it to enable and start. And then we actually put some templates in there, which is fairly simple, just vars.xml and distributor.conf.xml, which are the only 2 XML needed here for our FreeSWITCH server to be able to run properly. And finally, we put a new SIP profile, external profile, which is for the SIP trunking, our own SIP trunking solution, just to be able to send our calls somewhere. Okay, so with that, these 2 files are all that's needed to get a fully working and running FreeSWITCH server on AWS. I'll also add that basically to run properly on AWS, you only need one tweak in the FreeSWITCH files, which is to turn on the aggressive NAT detection. Otherwise, FreeSWITCH doesn't work really well on AWS. You'll get into some NAT issues, but if you turn that Boolean on, aggressive NAT detection, you'll be able to run just fine. Now, I talked about a OpsWorks CLI that we made. So we made a tool. We wanted our dev team to be able to not care about how deployments have to work, how provisioning works, and give them a tool to do that simply. So we made a tool that comes with an interactive prompt, first of all. so that if they want to deploy code into a certain stack, it's fairly simple. They pick deploy code, and they can then go through our stacks. So for example, I could pick, let's say, like production SMS. I'm not gonna do it, but still, they could pick an app and then choose the layers on which they want to deploy this app. So it could be one or multiple layers. And if they press enter here, it would deploy that app to those layers on this stack. So it comes with a few useful things like that, or you can also inspect your load balancers. The elastic load balancers are one of the great AWS features, but we wanted to give a simple way for devs to check if something is wrong quickly. So for example, if I check my ELBs here, I'll be able to see that my ELBs are running fine. I can see my instance types. I can see that they're online and running fine. And also, this comes with a way to actually run the commands here by the command lines. For example, if I want to run an update on all my FreeSWITCH layer, I can actually use that. Oh, typo there. With a simple command, I can tell it to run an update on all of my layers called FS for FreeSWITCH. But this does actually aggregation on all your stacks worldwide. So if I did layer media server and profile staging, that's going to target our staging media servers. And I don't see, did it match anything? It's hard to tell from here. Is there anything displayed between running update and confirm the command? It's hard to see. Do you guys see anything? Okay. There you go. Okay, so layer media server profile staging, and now this would run update on all my staging media server stacks here. So it's gonna, let's run it. So it's gonna run that command on those 5 stacks and monitor the command running, and in like 25 to 30 seconds, it should tell me that it has updated the cookbooks on all the instances of all those stacks. So it gives you a really nice abstraction layer to run commands on all your stacks. So as I said, think about setting up new users and things like that. It makes it super easy to do. So the OpsWorks CLI, it's open source. It's on our GitHub. There's a link at the end if you want to have a look. It has a pretty good documentation as well. That's pretty much what it does. Let me come back to the presentation here. So the cool things that we could have done with a bit more time, we could have some failover. We could add an elastic EIPs to our servers so that we could have failover with FreeSWITCH and recover the calls if there's a crash. That's really easy to do with AWS. You would have one elastic IP, which is a public IP, and it would be floating between our 2 instances. And when one goes down, you would reattribute it to the other one, and you would instruct FreeSWITCH to recover. We could also add some custom CloudWatch metrics. As I said, we could have a number of calls on the FreeSWITCH server. That could be a rule to scale up and down. We could have some graceful shutdown recipes so that our server stays up for, say, 1 hour and wait for the calls to finish. There are many things that can easily be done like that, but in 25 minutes, it's short to cover all those use cases. I want to talk just quickly about Zentrunk. So that's our product that we released a month ago. It allows you to basically not have to bother with contracts, with minimum spends. It has voice calling to more than 200 countries, inbound calls to more than 55, and instant phone number provisioning. And it's super cheap as well. So if you want to have a look at that, you can also hit our website, or you can come to our booth and have a chat with us. So do you have any questions? While I take questions, these are the things that I've talked about, if you want to have a look at those.
Any questions? There we go. One in the front. Let me grab the mic to you.
Do you guys evidently use FreeSWITCH? Do you have any like high availability needs? Do you have problems with failover with the high availability?
So we're experimenting with failover. The problem with failover is that our stack that drives the calls isn't really stateless. cannot at this moment recover on another server. So our stack is the blocking part of it right now. So we're trying to work that and to rewrite a part of our stack. We're trying to switch to Go for that part of our stack and have something more modern and more flexible, but that's the blocking part for us right now. Any other question?
Okay, one more question, and then back here in the back. And then afterwards, you'll have to grab Tristan in the hallways.
Hi. What's the, you mentioned that you're routing media through FreeSWITCH, so are you using public IPs, or in AWS you only get private IPs from them? Are you running FreeSWITCH behind that?
So we're using public IPs. As I said, we use elastic IPs. The servers obviously have also private IPs. We try to put all of our servers in a VPC and a virtual private cloud so that only those servers can connect to other resources, just to encapsulate all of this. And yeah, as I said, just public IPs. All right.
All right, well, thank you.
Okay, I'm gonna be available in the hall if
grab
anyone wants to talk about that, about DevOps in general or DevOps for FreeSWITCH. Thank you.
Absolutely, grab him in the hall. Thanks, Tristan.